Okay, so from worksheet 3, question number 5, at the melting temperature of Tm of protein, if Tm equals 55 degrees Celsius and delta H for the unfolding, delta H equals 15 kilojoules per mole. For this problem, you should assume that delta H and delta S are temperature independent. So for part A, it says, what is the delta G of unfolding at the melting temperature? Because we can assume that this solution is at equilibrium, we're going to say that delta G equals 0. For part B, we are going to estimate the delta S for this process. So delta G equals delta H minus T delta S. And then what we're going to do is use the information in the problem and we are going to plug it into the equation that we have here. So we already know that delta G equals 0. And from the problem, we know that delta H is 15 kilojoules per mole. We need to go into joules, so we're going to write that as 15,000 joules minus the temperature, which in the problem we see it's in 55 degrees Celsius. We're going to change that into Kelvin by adding 273. So we've got 55 plus 273, which is 328 times delta S. And then all you have to do is solve for delta S. And when you do, you see that delta S equals 46 joules per mole times Kelvin. That's part B. That is the estimate of delta S for the process. Now we're going to do what is delta G at 25 degrees Celsius for the unfolding of the protein. We're going to use the exact same formula, which is delta G equals delta H times T, not times, pardon me, minus T delta S. And we are going to, once again, just plug our numbers in. So delta G equals 15,000 joules. Remember, we changed it from kilojoules in the problem to joules in our solution, minus, then we got to change our Celsius into Kelvin. So we're taking 25 plus 273 gives you 298 Kelvin times, and then we're going to use our delta S from the problem above, 46 joules per Kelvin. And that gives, if you do the math for that, and that gives you 1,292 joules. All right, part D, which is find the equilibrium constant for the protein unfolding at 25 degrees Celsius. All right, now we are going to use a different equation for this. We are going to use the equation delta G equals negative RT natural log of K. All right, we know that delta G at 25 degrees Celsius equals this right here. We already solved for that. So we're going to plug that in. 1,292 joules equals, and then R is a constant, so negative, and then we're at 8.314 joules per moles times Kelvin times 298 K, because that is what 25 degrees Celsius is in Kelvin, natural log of K. You do the math for this, you're going to solve for K, and K equals 0.593. So that is the equilibrium constant for the protein unfolding at 25 degrees Celsius. If you have any questions on how to do the math for that, you need to come see me.